All right, we're going to seem to be switching gears here with section 5.4a, and we're going to take a look at simplifying radicals. But when we get to 5.4b, you'll know why we're practicing all of this. So the first thing I want to do is review the perfect squares. Hopefully you've got the majority of these memorized. And then as you look at some of the bigger numbers, 20 squared equals 400, you notice a pattern based on 2 squared equals 4. So I'm not going to go through all of these, but if you need to jot them down, remember there's also the PDF on my website. All right, so the first thing we're going to do is look at simplifying some basic radicals. Simplify completely. Now our first example is the square root of 32, which is not a perfect square. So here's how we simplify it. We look for a perfect square factor, meaning what number that is a perfect square goes into 32 evenly. Well, probably 4 jumps out at you. 4 is a perfect square, and it is a factor of 32, but there's a larger one. 16 is a perfect square and goes into 32 evenly. So here's what we do with that. I'm probably going to show a little bit more work than I described over here for the first one, and then I'll shortcut it a little bit on the second one, but I want you to know where this is coming from and why this works. So what we can do is we can rewrite 32 as the square root of 16 times 2. We're just changing the way 32 looks. Instead of leaving it as 32, we're just rewriting it as 16 times 2. And what we can do is take the square root of 16, which is 4, so that comes outside the radical. 2 is not a perfect square, so that stays under the radical. So that's what my step 2 is about. Take the square root out, leave the rest under the radical. I think that might be my only steps. Okay. So let's look at part B. I'll probably show this the long way one more time, and then on C, maybe I'll shortcut it to how I usually do it. So perfect square factors of 60. Well, I'm getting 6 times 10, but those aren't perfect squares. 4 goes into 60. If you can't think of a perfect square factor off the top of your head, you can always use factor trees. So let's say with 60, I had no idea that 4 was a factor of 60, but I do know that 10 times 6 equals 60. And then I factor it into the primes. And anytime you find a pair of the same number, 2 times 2 is going to give me 4, which is my perfect square factor. So 2 is the square root of 4. That comes outside the radical. What's left? 3 times 5 is 15. And my last one, 125. Well, I know that 125 is 25 times 5. Square root of 25 is 5, and 5 was left over. So let me show this the long way since I got the same numbers in case you're confused as to what happened there. 125 is 25 times 5. The square root of 25 came out of the radical. 5 was left over and stayed under the radical. Let's take a look at rationalizing denominators. The concept behind rationalizing denominators, or why we have to do this, is to put it in simplest form. So remember, anytime your answer is a fraction, you need to simplify your fraction. Well, same with radicals. And simplest form is defined by not having that radical in the denominator. So here's what we do. My step 1, I might have to explain this a little bit if you've never seen that term foo before, it stands for fancy form of 1. So we need to multiply by a fancy form of 1 to cancel the radical in the denominator. Well, where do we come up with this fancy form of 1? It's the radical in the denominator, because when you multiply a square root by itself, the square roots end up canceling. So I'm going to multiply by the square root of 6 over the square root of 6. And I'm going to show you this the long way just once so that you know why those square roots cancel. So multiplying fractions, we multiply straight across. In my numerator, I get 3 times the square root of 6. And in the denominator, I'm going to multiply those together under one radical and get the square root of 36. Well, what is the square root of 36? 6. All right, now any numbers outside the radical can be simplified. So I've got 3 over 6, which simplifies to 1/2. Second example, 7 over the square root of 20. I'm going to multiply, sorry, I forgot my steps. So I'm going to multiply by the square root of 20 over 20. And I'll follow my steps this time. So I'm multiplying by a fancy form of 1 to cancel the radical in the denominator. That was my step 1. And then on part A, square root of 6 was already simplified. However, on this one, 20 is not simplified. So the perfect square factor of 20 is 4. So I'm going to pull the square root of 4 outside the radical. 5 is what's left over, so that stays under. That wasn't clear. Remember, 20 is 4 times 5. So the square root came out. 5 is not a perfect square, so that stayed under the radical. 20 is in the denominator. And then 7 times 2 gives me 14. 14 20ths can be simplified. Dividing them both by 2. I get 7 times the square root of 5 over 10.